Hello?
Yes, yes, yes. Okay, but I always have to like switch between draw, move.
Wait, you're unmuted on the Zoom.
老师好。
Say like afterwards.
Good afternoon.
Are we going to start?
I will start at around 6:30, or maybe a little after 6:30, as soon as everyone comes in. And for those of y'all in Eastern time, that will be 7:30. So
How to get more stars is you basically get more. When that B0
Good evening, everyone. Can everyone hear me?
Yes.
Okay. My name is Daniel. I will be your, I guess, 老师 teacher for this class. I guess a little bit about me. I'm a recent graduate from the University of Texas at Austin, and I'm not too familiar with some of the Chinese characters. So for those who do have them, can you please put an English name that you would like to be called as well? Just rename yourself, and then I'll be able to just call on you that way. So let me share my screen. Also, if you don't want to turn on video, that's fine too. If you do, that's also fine. I won't require it. Can everyone see my screen?
Yeah.
Yeah.
Okay. So the first couple of chapters that we will cover will be shapes for chapter 1, multiplication for chapter 2, and exponents for chapter 3. This will be kind of a backwards classroom where you'll kind of read through the material on your own for homework, and then I will work with you through some of the harder problems during class. But for today, I'll just go through kind of the first 3 chapters. So this is the contents of chapter 1. So we'll first go through definitions, then about angles, parallel and perpendicular properties, symmetry, and then I think these 2 are characters, and so they have some fun little stories at the end. But as you can see, this is kind of just a comic book for y'all to read through. So I think it'd be a lot more useful if I went through problems during this time period instead of just reading the comic book, which y'all can do on your own to you guys. Does that sound all right with y'all?
Okay.
Great.
Oh, will we have the textbook?
So I believe you should have purchased this. If I'm not mistaken.
We have we can release this to a Padlet and like a Google Drive. So whenever when you guys get this for homework, we'll just post it and then you'll be able to see it from there. So yeah.
And I guess one last thing, if people could kind of just raise their hand if they want to, if they do a chat or are typing in chat or want to answer, feel free to unmute yourself and kind of just ask questions along the way while I'm going through material. I think that's pretty fine. But when I'm sharing screen like this, unfortunately, I can't see the chat. So if you could, I think there is a kind of raise your hand pop-up that you can do. And then I'll see that and then I'll stop and respond. Yep, just like that, Brandon. So with that being said, the practice will look like something like this. And I think, as Kital mentioned, there will be Padlets for this if you don't have it, I think. So my idea is that the first probably like 2 parts of a questions you will probably be able to do on your own since they seem more straightforward. And then during classes, after you've read through the required pages or the related material, then I'll go through the relevant material as summary, and I'll also review some of these first two practice problems for each chapter, but I won't go and do them directly. But then for the harder practice problems, then I'll go through and actually do them. And I'll let you guys know what I expect for as homework. So I'll tell you up to problem or up to page, whatever in the practice section. With that being said, since there's not much I can do in terms of practice, since you guys haven't read the material, I'll just start reading from here, if that sounds fine. Or if we have a guest reader, any of y'all want to do a guest reading? All right. In that case, I'll start. So we have two people here. Eric?
My living room. Are you letting me read?
Yeah, do you want to be the blue?
Okay.
Okay, I'll be orange then. So what are you working on?
Mrs. Q left this in the copper. It's tonight's geometry homework.
You brought homework on our fishing trip?
I wanted to give it a try.
Let's see what you have so far.
Most of these words are pretty easy.
So here on the page, it says, define each of the following. Point, what do you do when you want to show someone something? Line, the string you tie to your fishing hook. Segment, part of a worm. Ray, a drop of golden sun. Angle, a funky word for fishing. And plane, a flying vehicle.
Fancy. It says fancy.
Fancy. Oh, yeah. Thanks for that. I don't think these are the definitions Miss Q is looking for.
Huh?
These are all geometry words. Miss Q is probably looking for math definitions. Let's look these up.
You brought your smart fly on our fishing trip?
It has a high resolution sonar imaging fish finder.
Okay.
Do you want to continue or?
Okay. What's the math definition of point?
A point is an exact location.
Got it.
Wait, there's more. A point has no size, only position.
Huh?
I think it means that a point is a location, not a thing, like the center of a circle. So instead of this whole place, it's just right there. A point is usually marked by a dot and a capital letter, like this. Here we have the dot and we have a capital G. So usually we name points with capital letters. Here it says G, but usually they can be in any form of the alphabet. So like A, B, C, X, Y, Z. Those are probably the more common ones. What's the next word?
Line.
Okay. Does someone else want to take a turn and read? Okay. I think I saw Vivian's hand first. Do you want to unmute?
What should I be?
Take a pick.
I'll do the orange guy.
Sure.
A line is a straight path that goes forever in both directions.
Forever?
That's what it says.
What's at the end?
There isn't an end. A line goes forever.
If a line goes forever, how do you draw it?
We usually put arrows on it.
So you know it keeps going?
Right. A line is usually labeled with 2 points.
Yeah, and so it's a straight path that goes forever in both directions. And usually we just note 2 points on the line. So here, like it said, a point is marked usually with a capital letter. So here's capital A and capital B. And then the name of this line is AB or BA. Either way works. Although I will say AB with a line on top is probably more common. The next word is segment. What's a segment?
Part of a line from one point to another is called a segment.
Like this?
Exactly. The point goes at the ends are called endpoints. The part of a line that starts at one point and goes forever in one direction is called a ray.
Yeah, that's true.
The point where the ray starts is called the origin.
Origin. Got it. So here, this is our origin, in this case, x. So it's part of a line beginning at one point and going forever in the other direction. And since we skipped it, but segment here, we'll have two endpoints. And so none of them are origin since there's two of them. And it's the line between the two that is called a segment. What's the math definition of angle?
Two rays that start at the same point make an angle.
I remember now. A right angle makes a perfect L.
That's right.
That's what I just said.
I mean, that's correct.
How's this?
Looks good.
So here we have two rays that meet up at this one single origin point, N. And they extend to R and to G. So we will call this angle like R and G, or also you can say G and R. But the N has to be in the middle because it's not R, G, N. The line goes through this way.
Let's define the last word so I can start fishing.
Okay, look up plane. Can I have another audience member? I see there's 5 of you who have raised their hand. Sean, do you want to have a go at it?
Okay.
Who would you like to be?
Blue one.
Sure. A plane is a flat surface with no thickness, but endless length and width.
Huh?
On a calm day, the surface of this lake is like a plane. The water surface is flat and it has no thickness.
But the lake ends while a plane goes on forever.
Right. So a plane is just an endless flat surface.
I wish this day could go on forever.
So I believe this is the end of our first section on shapes. So the upcoming one is measuring the angles. Before that, since we finished this chapter, I will now cover some of the problems here. Let me see. Yep, 14 through 18. So that was the end of our first little story. Can I have someone come and I guess I'll call on you all. So Maggie, since you have your hand raised, do you want to answer the first group of questions?
Sure.
So what is a point? Do you remember?
An endless flat surface with no thickness.
No, I mean, as in like, what's the definition of the point? Yeah.
An exact location.
All right. So then this would be drawn here. Unfortunately, I'm on the a PDF, but I can, let's see. Let me, okay. All right. And then the next one.
A line is a straight path that goes forever in both directions.
Right. And then third one.
The part of a line beginning at one point and extending forever in one direction.
So that is actually ray. Ray starts at one point and extends on forever. A segment has one part of a line going from one point to another. So remember, a segment is like this. It will have one endpoint and it'll go on to another endpoint like this. And so it has, it doesn't extend forever on any side. So then a ray, on the other hand, goes like this, and it will go forever. Does that make sense?
Yes.
Okay. So, and then I guess just to recap, this is the origin. And then segment was part of a line from one. And the last two, do you know?
An angle is two rays that start at the same point.
Correct. And the last one? I guess this one's kind of obvious now that there's only one left, but. Right. So the plane will be an endless flat surface with no thickness.
And a plane is an endless flat.
Exactly. Does someone want to, I guess, do this next problem? Let me see. Brandon, do you want to attempt this since your hand is raised?
Okay. So the point is.
Hold on 1 moment. Let me hear that.
The point is the second one.
This one?
I think so.
So this one's actually the ray, because this is the origin part. And then for the ray, it only extends in one direction, which is why we only have one arrowhead. Does that make sense?
The third one.
Yeah. So the point is actually the third one. It's a single place or an exact location, as shown right here for Q. Do you know which one this one should be then?
Is number 10?
Yeah. I don't know who shouted it, but yeah. So this one is the ray. And then, do you know what a line should be, Brandon?
It's the very last one, right by the one that's the acute angle, just right by it.
This one?
Yes.
So this one is the segment actually. A line is a segment, except it extends on both sides.
Oh, it's the first.
Yeah. Does that make sense? So ray only extends in one direction, line extends in both, and then a segment extends in 0 directions. And then you got this one right. And also this is an acute angle, but I don't think we've covered it just yet. But
plus the right angle is a 90 degrees.
Yeah, that's also true. But as you said, this is the angle, and in fact, it is an acute angle. So what Brandon was talking about before just now was a 90-degree angle. Looks like an L, and we saw that also in the storybook. in the example. Let me go back here. This one, he talks about a right angle makes a perfect L. And so this right here would be a right angle. And usually people denote it as such, with a square right here. So this is kind of a little off topic, but since we're kind of just blasting through the section, I think that's fine. So we have three types of angles. There's acute angles. So things that are smaller than 90 degrees. This, that's a terrible drawing, like that. This is the acute angle. Let me see if I can this. And then an obtuse angle would be, okay, so this is the acute angle. And then this angle right here is greater than 90 degrees, and it is a obtuse angle. I know it's a little hard to read, but essentially greater than 90 is obtuse and less than 90 degrees is acute, and a 90-degree one is just the L-shaped. Oh, that's not my mouse. Oh, sorry about that. Okay. Can I have another person volunteer for this group of questions? I think Julia has her hand up. Do you want to unmute and let's try going through them?
Okay. So the points are K, L, and M.
Right. And that's because these points have only, they're only one location, or they're just one exact location. So we have a line segment is named by its endpoints. The order of the points don't matter. So segment KL can also be named.
Okay.
Yep. Lines can be, hold on, let me just scroll this down a little. Oh, kind of sad. Okay. Okay. Lines can be named using any 2 points on the line. The order of the points don't matter. One way to find the line above is MK. Find the other 5 ways to find, to name the line MK.
So K, L, M, M, OK.
I'll take that. And then,
And
so really, what are these? This is K to M.
Yeah.
People, I think, denote it with that line. And then this is the opposite of that, right? MK.
Yeah.
Although they did ask us to find other 5 other ways besides MK, so I guess we can't actually count MK.
Okay. So KML.
So a line only needs 2 points to define it. So I think, for example, the other lines that we could define this is L and M, right? Because, yeah, okay. And then there are 3 more.
KML.
So we only need 2 points on the line, and this is not, so for angles, we would need 3. And you want to, you don't ever want to kind of jump around points, because that would assume that we have a way to get from K to M and then back to L, right?
Okay, so
if L to M from L to M is 1 line, is there another way we can name LM, kind of like what we did over here?
ML. ML.
Yeah, I guess ML is the other way. Can we try? I would like for people not to just jump in when other people are talking. Maybe give them a chance first, like a couple moments.
OK, L, and LK.
Right. So those are the other two. And these are our 5 different lines that we have. Okay. And then last one, or I guess last 2.
Daniel.
Sure.
You need arrows above the line. Otherwise, your line segments.
Okay.
You need to draw arrow, yeah, on both sides.
Okay, got it.
Can you explain it? Can you explain again? I kind of don't get it.
Sure. Do you mind telling me what you don't get?
I don't get, for example, like KM.
Mhm.
Or I mean LM. I don't get it because it's not like a full one. It's like half of it or something.
Right. So when we're talking about line segments, that's true. But a line is just a line only cares that it's extending forever, right? So even if we said LM right here, with this would be the line segment from L to M, but a line doesn't really care about that because it will go on forever. And so it will also end up passing point K. But to define this line, we don't have to include K. Think of it like, have you worked with a ruler before? Okay. Yes, no?
Yes.
Okay. So when we have a ruler, right, we kind of draw from one end of the ruler to the other. So it might be like, there might be a couple inches here. So like 1 inch, 2 inch, 3 inch, and then dot, 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 right? But when we draw this like line on the ruler, even though we draw from like say 1 to 3, and then we draw arrows saying that it goes on forever, we could have also just drawn it from 1 to 2. And if it was in the same direction, since it's going on forever, which means we expect it just to kind of continue this way. It's as if we could draw in forever, but we can't draw forever because we don't have a ruler that goes on forever, but they represent the same thing. So these two would then be equivalent. They're really, the length doesn't really matter, or how long the line you draw, just that it all falls in kind of, the points will all just, I guess, go through. So if I added another point here, I guess, you could have called this line, say, let's just put J here. Then this could have also been like line J to M, because drawing a line from, kind of a line between J and M will also cross K and L because they go on forever. Does that kind of make sense, or are you still a little lost?
I think that makes sense.
Okay. You would be correct though about line segments. So if I have a line segment from K to L, where it's just, or K to M, sorry, then this line segment does not equal, does not equal like L to M, because we're missing out K that's over here. So we're missing this part of the line, right? But a line will extend forever, and it's not only just a small portion of it. Did that, I guess, clear up any further issues?
I think I'm done now.
Okay. We were at 15, right? Sorry about that. Okay, Maggie, I think this was still at you, right? So array is named by its origin and any other point on the array. The name of array can always begins with the origin. So ray KM can also be called.
It can also be called KL.
Right. So unlike our line segment up here, because we are a ray, we have to start with K. But unlike a line segment, it doesn't matter. We can choose any point on this ray to call as our other point. So if there was like point L right here, we could have called it, or point M. So this is the similar concept with a line versus just a segment. And then I think the last question, can ray LM be named any other way using the given points? If so, give one other name. If not, explain why.
May I answer?
Yeah, sure.
It cannot because between L and M there are no other letters before or after.
Right. So I guess to put it more, to put it better. Sorry, did I just drop for a second, by the way?
No, you're good.
Okay. Let me just do this then. So, yep, you can't do this because our starting point has to start from L. And then since we are going to M, we don't have any other points in between. So we can only use M as our current point. If they did have a point, say over here, let's say N, then we could have also named this LN. And N could be here, or N could have been here, or wherever on this, I guess, line. It doesn't really matter. Then we could have used it. But since our only point K is behind the ray over here, our ray isn't actually going, backwards and then looping around somehow. So we can't actually get to this point. But yeah, that's a good, correct answer, Maggie. All right. Now on to angles. So this one, it says name the angle in the diagram below. So usually you can call it either XYZ right here, or ZYX. And then that's because we can go from X to the origin Y and then back out to Z, or vice versa, from Z to the origin Y and then to X. So this is no longer called an origin when we talk about an angle, but instead they call it a vertex. So these are kind of defined with just 3 points. So 1, 2, 3, and then having 2 lines start from the vertex going through your 2 side points. Does that make sense, everyone?
Yeah.
Okay, so can I have a volunteer for this set of questions? Sean, would you like to go again for the first half and then like say the first 3, and then is it Eric? Would you like to go for the next 3?
Okay.
Sean, are you there?
Yeah.
Okay. So the question is, use the diagram above for the problems that follow. Connect each angle name on the left to the name on the right that describes the same angle.
A
So-
B D D B. Wait, let me see.
So ABD is this.
DBA.
Yep, DBA. So we go and get this one down here.
BDC CDB.
BDC CDB. Does everyone see that?
BDC CDB DBC CBD.
And then the last one.
CBD CBD.
Yep. And then can I get Eric to answer these three?
Okay, so angle CBA is angle
CBA,
ABC.
ABC. All right, that's correct.
And then angle ADB is angle BDA.
Yep. So essentially, it's just swapping these two characters, if people haven't realized, because the middle character will always be your vertex. So here, A and B just swapped, and D was kept the same. Make sense, everyone? All right. And then the last question, Eric. Angle BCD can be named 4 different ways. Find the 3 other ways to name angle BCD. So B, C, and then D is this one.
And then maybe DCB.
Did you say DCB?
Yep.
All right, that's one.
I can't get the other one.
Okay, so remember that an angle just needs to start from a vertex, but it can go on, the segment or the ray can extend on for a while. So remember what we did with rays, where we had a later point. Is there perhaps a later point that you see that could extend this angle?
Could I do like maybe ACB?
Yeah, exactly. So that's another one. And this is because we keep the same vertex, and D and A lie on the same line. So our angle will always be the same, even though point D is over here and point A is over here. That doesn't really matter, since this, I guess right here, if you guys can see this. This right here is our angle. So the last one should be short and simple.
BCA.
Yep. And those are our 3 other angles. Does that make sense to everyone? All right.
Yes.
Sounds good. I think this will be the last page for this short section, if I remember correctly. 23, 24, 25, and 26. And I think if you do see star questions in your kind of workbook, there are hints to these star questions because they are supposed to be questions that are a bit more difficult, but we'll see, right? All right, can I get someone to, I guess, answer these first 2, and then another person to answer the last 2? Okay, I saw Maggie, you still have your hand up? Do you want to answer the first two?
There are three segments, X, Y, Y, Z, and XZ.
Okay. Can you repeat that real fast? I didn't quite catch all of them.
X, Y, Y, X, no, Y, Z, and XZ.
Right. And then since they're line segments, I'll just draw them like this. So there are 4 different arrays that can be named using the given points. Do you want to name all of them? Maggie, I think you're muted.
X, Y, X, Z, X, Z.
Okay. I think that should be the same array. It's just a different naming.
Yeah. So X, Z, Y, Z.
Right.
And Y, X.
Right.
And Z, X.
Right. So do you know why I did not want to count XZ?
Why?
So XZ right here, this array, since we're already going in this direction, would be the same as this array because the line will extend forever. So they are different names to both the same array.
Okay.
I don't know why that went so big all of a sudden, but yeah. But the other ones, for example, like YX, will go this way. And then you also said ZX. ZY would have also done the same, been the same. And then last but not least, YZ. So do you see, I guess, how these are all kind of different? So parts of this is because we start at one origin and continue forever. So we are starting at different origins in these cases and just going in different directions. And that's why we have 4. All right, can I get, I guess, Vivian, do you want to do the last 2?
FEG.
Okay. Let me scroll this down real fast.
GEF.
Give me 1 second, sorry. Okay.
G
You said FEG?
FEG, GEF, GEH.
GEF. Let me just rewrite these. GEF. Did you say GEF, by the way?
I did GEF.
Okay, so FEG and GEF, they are both the same angle. Does that make sense? But we have
FEJ. I mean FEH.
Okay, that's another one. And then there's one more. So I guess the first one that we named was this one.
GEF. No, GEH.
Right. Does everyone see that? We have, in this case, these notations. This is our first angle right here, FEG or GEF. This one is our second one, GEH or HEG. And then our last one is this big one right here, which is FEH or EHF, or sorry, HEF. All right, and then the last one
Okay. EFG. EGH.
Sorry, EFG was the first one you said?
Yeah.
Okay. So that's this angle.
EGH.
EGH, this angle.
EGF.
EGF. That's this angle.
HGF.
1 moment.
HGF and then HEG.
You said HGF.
Yeah, and then HEG.
Then
HEF.
Okay, let me draw this. HGF is this big one. HEG is this one. And then you said what was the next one that I missed?
HEF.
HEF, yep. That's this big one.
No. Yeah.
Yeah, we haven't gotten that one yet, I think.
GHE and then
GG.
GFE.
Yep, G, or we already have GFE with EFG.
Oh, really?
This angle is already done.
GEF.
Yep, the last one that we haven't done is this one right here. GEF. So essentially, these are all one angle. And then we have these two mini angles inside for each of these. And then we have this one big angle right here where we combine the two smaller angles inside. And that gives us a total of 8. Make sense, everyone? And then similarly, you can always swap these around. So this, once again, is equivalent to GFE, and same for the rest of the others. Those would all be equal to the same angle. Is there an F, G, and H? Yep, I believe we did say it with HGF right here for Aaron's question. Does that make sense, everyone? All right. I think this should be, I believe, the end of this section. Yep. We have 10 more minutes, I think. So hopefully we can get through this story real fast then, you know? Can I get a volunteer reader then? Okay, Aaron, do you want to go for it?
Okay.
Okay, who do you want? I think I might need 2 readers. Or actually, I'll just do these 2. And I'll do...
May I?
Do you want to read? Who was that?
Sean.
Sean, you want to read? Okay. So I believe there's
And
this...
me. I'll be the pink one.
Who wants the pink one? Sorry. Aaron? Okay, so you want the pink one. Sean, do you want the purple one then?
Yeah, I like it. It's really funny.
Sure. Okay. So Aaron and Sean.
2 rays that start at the same point from an angle. The point where both rays start is called the vertex of the angle. Today we're going to learn how to measure angles. When comparing angles, we say that an angle is larger if it is more open and smaller if it is more closed. For example, how would you compare the sizes of these 3 angles?
Okay. So the first angle is the most open. And as you can see, if you tried to kind of use your arms, you'd have to make your arms pretty big to make such an angle. The next one, also, I guess, kind of to remind, this is also known as an obtuse angle, as it says right here. The second one is more closed, but it's still pretty big, and it's a 90-degree angle, like our L shape. And this one is called a right angle. And then the smallest one is an acute angle, and it is the most closed of the three. So for size comparisons, obtuse would be our biggest, and then right angle would be our next biggest, and the last biggest or smallest would be our acute angle. Does that make sense, everyone?
Yep.
All right.
Good angle are measured in degrees.
With a thermometer?
Thermometer?
Not with this.
How do you take an measure angle's temperature with that?
Let's start over. Temperature degrees are different from angles degrees. We use a protractor to measure the number of degrees in an angle.
Not a protractor, a protractor.
A protractor is usually a half circle with degrees marked from 0 to 180 around the outside. To measure an angle, place the center of the half circle on the angle's vertex. Each ray should cross a degree mark along the outside of the protractor. Turn your protractor so that one ray crosses the 0 degree mark. The degree mark where the other ray crosses gives you the angle measure. This is a 65-degree angle.
So
okay.
Yeah, I can kind of go from there. So this little round mark right here is what we note as degrees. Unfortunately, it's also the same in the case of temperature. So you'll also have degrees here, but usually you'll have a C or an F for temperature. And if it's for just regular angles, then we only have the degree sign. Let me see. All right. I guess real quick to recap, does that make sense? So when you get your protractor out, kind of rotate it so that one ray starts on 0. That way you're going from 0 to wherever the other ray hits. In this case, it's 65. So we have a 65-degree angle. And also note that the rays extend outwards. So where the protractor is will always kind of tell you what this angle right here would be. All right, I think Sean, you're up next. As soon as I scroll down.
I forgot to turn my protractor, but I still got 65 degrees. This ray crosses at 16 degrees, and the other one crosses at 81 degrees. So there are 81 minus 16 equals 65 degrees between the two rays of the angle.
That's right, Grog. You can find where each ray crosses and subtract to find the number of degrees in the angle. But it's easier to place one of the rays to 0 so you don't have to subtract. Try measuring this angle on your own with a protractor. You try to.
Yeah, so if everyone has their protractor, like Aaron's kind of showing, you can take the book if you have it and measure it here. Alternatively, we have a picture right here. So we can, for those of you without the book, I will just read this part. So the turtle here is, I'm confused. There are two sets of numbers on my protractor. Is this angle 28 degrees or 152 degrees? So most protractors have two sets of degree marks, like the one shown right here. So for those of you guys who measured, what do you think? Or I guess anyone, what do you guys think? Would anyone like to respond? I guess I see Kathy just raised her hand. Do you want to?
I think it's 28.
Okay. Can you give me a reasoning?
28 is less than 90 degrees.
Right. And this angle right here looks to be an acute angle, right?
Yes.
Is there another way you could have, or is there any other reason that you can think of why this should be 28 instead of 152?
The bottom arrow is pointing to the right.
Right. So this arrow right here is pointing at, in this case, we seem to be starting from this 0 right here. And then that's why we are using the bottom numbers to go up to 28 or over here. Another way, as we kind of just showed above right here, if you have two degrees or your two rays that are not on the same, not at the 0 mark, that's okay. You can still find how, what degree this angle is by just subtracting the larger number from the smaller number. So in this case, even if we started at 180, we would be doing 180 minus 152, because this angle ended up at 152 right here, and this one at 180. And that gets us our 28 degrees. So this angle is indeed 28 degrees. And I think for most questions like this, since it's so easy, a quick inspection that, yes, this is under 90 degrees is usually the faster way to go about things. So good answer, good answer. Does anyone want to be, or I guess read through the other characters?
Can I?
Sure.
Oh no, see, my sister's crying.
I have an idea. We can compare it to a right angle. Every right angle has the same measure, 90 degrees. I see. Since the angle is
acute,
it must be less than 90 degrees. So it can't be 152 degrees. It must be 28.
Yep, and this is the same answer that I think we were given just now. Erin, would you like to continue?
That's right. Every acute angle is smaller than 90 degrees, and every obtuse angle is larger than 90 degrees. There is a 28-degree angle. Now that you can measure an angle, let's try drawing an angle with a given measure. How would you draw a 103-degree angle?
And then Maggie, I think this is you. But yeah, so we should start by drawing one ray. The hard part is finding where the other ray should go. But one ray, you can start it anywhere. So the, I guess, easy way is if you do have your protractor, you can place your protractor down with one ray here. And then you can follow, since it's easiest if we start at 0, but you can follow it all the way to 103 right here. And then draw your angle this way. Does that make sense, everyone? How I would get to a 103 angle? Alternatively, if the ray started going this way, you could have also used this 0 and then gone this way and hit 103. All right. I think we'll end this right here. So just to quickly kind of cover what I would like everyone to do. So today we covered some of the definitions and some of angle measurements for chapter 1. If people could please finish the measuring angles chapter comic, the parallel and perpendicular chapter, and let's try the symmetry one too. If I can have y'all read up to page, in that sense, right before we do these 2 short stories, so up to page 38 for next week. Does that sound okay?
Yeah, I guess so. Wait, so what's the homework again?
Read up to page 38.
Do we do anything on the practice book?
You can. So I think if you have the practice book, you can start going through some of the questions. I'll try to spend most of my time next week just going through the practice problems from up to these pages, because I think that would be probably a better use of my time and your time rather than me just reading and you just reading. So does that sound good? So if you, in that sense, if you do practice problems, if you want to, you'll be able to hopefully easily answer the ones when we go through them next week.
I don't have the comic.
I think, Kisan, if you can correct me, but I think they will have it as pamphlets.
Yeah, we're gonna post it on like it's gonna be posted in the WeChat group that your parents should all be a part of. Yeah, so like it'll be viewable. There'll be a link for it.
Any other questions, I guess, before I end this first class?
No.
No, so we read to the 38th chapter of the comic book. Is that our...
Right, the 38th page of the comic book, that'll be the homework.
So that's our homework?
Yep.
Oh,
I think
wow.
we stopped on page 23, so it should be about 15 pages.
I did not expect that we were gonna read. I expected that we were gonna do some math.
Yeah, so I think it'll be easier for me to go through the practice problems in class. You can do, if you have the practice problems, you can of course do the problems that are relevant for these chapters, but I will go through them in class and kind of, in case you don't understand something or in case you end up missing something, that way everyone will understand how to do the questions and hopefully get a better idea on the material. Does that sound all right, Eris?
Yeah, okay, that's good.
All right. If there are no questions, then yeah, that's the end of class. Thank you for coming.
Okay, thank you for teaching us. Bye.
Thank you. Bye. Thank you. Bye. Bye.
Bye. Thanks. Canning. If you have a question, just let me know. Otherwise, I will end the meeting. All right, I will end the meeting now. Have a good day and have a good rest of the week.